In this lesson, we're going to take a look at how do I find slope from a picture. Now you have to remember, slope, which is m, is my change in y over my change in x. Now I would like to add in a symbol. Just like pi is a symbol that represents the repeating number, I shouldn't say repeating, but non-terminating, non-repeating decimal, 3.14, etc. There is another symbol that stands for change. So I want to introduce you to that symbol. The symbol is a triangle. Now this triangle is called delta. It's a Greek letter, just like pi is a Greek letter. And I won't get too much into that, but that's delta. Delta stands for change. So this is read change in y. Whoops. This is read change in y over change in x. So that's what slope is. Okay, so if I'm given a picture, how do I figure out what my slope number is? First of all, in my picture, I want to identify two ordered pairs. Well, here's an ordered pair, and the reason I'm using that is because it crosses at a perfect intersection. It's very clear to see that that is the ordered pair 1, 6. Okay, I gotta look. I'm going to look down my line. Can I find another perfect intersection right there? So right here is another perfect intersection. So when I go to figure out my slope, I'm going to make a fraction. I need my top number, my y value. Okay, well, how much should it change from top to bottom? Very simply, read this like you read a book, from left to right. So from my furthest left point, how far up do I go to get in line with my next point? The answer for this case is 2. I go up 2, so that's my top number. The bottom number is, what is the change in x? My change in x. Again, reading from left to right like you would read a book, from my first left point over how far till I get in line. It's 3. 3 to the right. So my answer here would be 3 to the right. What is the slope of this? 2/3. Now, I do always want to check that my fraction is reduced. Slope likes to be written as a fraction and reduced. How could I check it? Up 2, right 3. Up 2, right 3. My slope is continuous. It's the same pattern over and over. Okay? Check. Next. Same idea, bigger numbers. Okay? So I'm looking for a perfect intersection point. Well, here's one. And I'm looking from left to right on my graph, and there's another one. So slope is change in y over change in x. Fraction. Okay, so I'm starting to figure out my y direction. How many up? Well, 10, 20, 30, 40, 50. 50. Change in x. How many over? 10, 20. So my slope is 50 over 20. Now remember, slopes like to be written as fractions and reduced. So can I reduce my fraction? I can. I get 5 over 2. And this would work if I zoomed in and went up 5 over 2, up 5 over 2, up 5 over 2, up 5 over 2, up 5 over 2. It would work and would keep all the solutions on the same line. Check. What if I have solutions that look like this? Well, we know that my slope is going to be negative because it's going down. Same process, I just know that my fraction is going to be a negative. My other slopes were positive because they were increasing. This is a decreasing graph. So let's find 2 points that are perfect intersections. There's one. And I'm working left to right on my graph. And there's one. So I'm going to do change in y over change in x. y. From the left to right, I'm working to figure out what is my difference this way. Okay, now we're counting by ones. 1, 2, 3, 4. So it's 4. What is my change in x? 1, 2, 3, 4, 5, 6, 7. So my slope is negative 4 over 7. It's already reduced. I don't need to reduce it. Okay? So notice it was negative. It was a decreasing graph, so I put my negative sign out front at the beginning. That way I didn't have to try to remember it. If you want to, you could say, oh, down 4, right 7. So you also get the slope negative 4 over 7. Same idea. Check.